So we've talked about the two types of interest. So say we have simple interest and compound interest. Simple interest is simply only on the original value, whereas compound interest is on the previous value. We have calculated simple interest as PTR in terms of years. And we've also established that the compounding is done semi-annually, annually. So annually is how many times? Semi-annually, how many times? 1, 4, 2, 12, 36, 54, 365. This one is what?
Once. That's annually.
Annually. This one?
That's quarterly.
Quarterly. This one?
Semi-annually.
Semi-annually. This one? Monthly. This one? Daily. This one?
Weeks.
Weekly. This one?
The one for weeks
is this continuous?
This one is continuous, yes. Weekly is 50 what? 52?
52 years.
Yes. Continuous is this one here. Then we said whenever we're compounding, what are the two effects? Our interest rate is always divided by M, and our time is always what? Multiplied by M.
Multiplied by M.
Correct. So we also went to say for simple interest, PTR, and we have an example to say if you deposit 1,000 kwacha in an account earning 7% in 2 years, what is the accumulated interest? So our principal is 1,000, our interest rate is 7%, 0.07, and our time in years is 2. If this was in days, we would have divided by 365, weeks 52 as guided. So the difference between interest and the future value. So when we add this to the simple interest, we get the future value under simple interest. We also looked at calculating using compound interest. So future value is present value 1 plus r to the power t. So this is also, we can also use the tables, which I'll teach you later on. So if we're calculating the future value, suppose you deposit 1,000 kwacha at 7% in 2 years. What is the future value under compound interest? Present value 1 plus r to the power time. So in the first year, it will give you 1070. In the second year, it will give you 1144. So the difference between the 1144 and the 1,000 is what we call the compound interest. All right, so sometimes you may be asked to calculate the compound interest using a table. So they ask you, find the future value after 3 years at an interest rate of 7% if our present value was 1,000. So the present value, so how we calculate the future value, we just say future value is equal to present value, then you put the future value interest factor, the rate against the time. So what is our interest rate? 7%. Our time is 3 years. So you go under 7% and under 3 years. What figure is there? 1.2. Yeah. So here you just put where there's PV, we put 1,000. Where there's the interest factor, we put the figure we found there, which is 1225. 1225. Then when you multiply them, we get 1,225. It's very easy using the table. So if they told you, suppose you have 5 years and your interest is 6%, and you started with a present value of 100 kwacha. So the formula where there is present value, you put 100 kwacha. Then you check under 5%, under 6%, and 5 years. So you go to 6% under 5. What figure is there? 1.338. So 1.338. So when you apply these two, we get 133.8. So using the table is very easy. I'll teach you also using our formula. So now suppose you want to pay your school fees. These school fees are worth 5,000. That's the future value. And the interest rate is 8%. The interest rate is 8%. The time you want to receive that is maybe in 5 years, compounded annually. How much must you invest now? So that is called the present value. We know that the future value is called what? Present value 1 plus
1 plus
the part T. So to make this subject of a formula, what we do, we divide both sides plus 1 plus R to the power T. 1 plus R to the power T.
Collins, we can't get you.
Okay. So I was saying, sometimes questions will come in a way that you'll be asked, Helen wants to pay her school fees, which are 5,000 kwacha. how much must she deposit now in an account to earn the 5,000 kwacha after 5 years at an interest rate of 8%. So we use the present value formula where we have future value of 1 plus r to the power time. And this is the computation. So meaning the present value must always be smaller than the future value. Now let's see how the questions come in an exam setup. Mr. Tembo has 1,000 to deposit in an account that earns 9%. I've sent these questions on the group, so you can try them as homework. Mr. Tembo has 1,000 to deposit in an account that earns 9%. Find the future value after 5 years if it's computed at simple interest. So lead us through. How do we compute simple interest? Yes, simple interest is equal to what? PTR, correct. So P times R. Okay, what is our principal? 1,000. Our time?
5 years.
5 years. And our simple interest?
9%.
9%, which is 0.09. So what do we get? 1,000 times 5 times 0.09 to get how much?
450.
450. That is our simple interest. But it's asking us for what? The future value. So what is the future value? Simple interest plus what? The present value or the principal. So we have 450 as interest that we're going to earn. And we started with how much? 1,000. So how much are we going to have after 5 years? 1,450. So you need to follow the instructions very carefully. So that is how much future value we're going to have after what? 5 years. Most people ended here, they didn't get the full marks. So how about this part here? Find the future value if it's computed at what? Annual interest rate. So the compound interest for future value annual is how, what's the formula?
Future value is equal to present value. 1 plus R. The power T.
So 1,000. What is our interest rate? 9%. 0.09. And what is the time?
5.
5 years. So this is going to be 1,000 times 1.09 to the power 5. What do we get? 1538 point what? 0.62. So these are people's money. Please always include the ngwes there. Okay, so you can see it's higher when it's compounded than when it's simple interest. All right, suppose it's semi-annual. What formula are we going to use? Future value is equal to what?
Present value.
Present value.
1 plus R to the power
MT, right? So semi-annual means our M is equal to what?
2.
2, correct. So here we're going to have 1,000. 1 plus our R is what? 9%. 0.09 we divide by what?
by 2.
Then the 2 multiplied by the what?
by 5, so
by the time, which is 5 years. So here we're going to have 1.045 to the power what? 10. 1.045 to the power 10. So we're going to have 1552.30. So this is what? Semi-annually. The more we compound, the higher the figure. This is annually 1538, semi-annually 55 and 2. So the figure begins getting more. About quarterly? Who wants to lead us? Quarterly, what is our M?
it's 4.
M is 4. So what becomes our future value? 1,000. 1 plus the 9%, we divided by what?
By 4.
By 4. And the 4 will come here again, multiplied by the number of years, which is what? 5 years, right? So 0.09. So you start from this part here. 0.09 divided by 4. What do we get?
0.0225.
Yes. Then you power the 1.0225 to the power 20. Okay. Then you multiply by what? By 1,000. So you see the figure is becoming bigger. This is compounded what? Quarterly. So maybe I can modify it. Sometimes you'll be asked to find the effective annual rate. Effective annual rate has no time. It is given by 1 plus R to the power M A over M minus 1. So at quarterly, what is the effective annual rate? 1.09 divided by 4. There's no time under the effective annual rate. So here we're going to have 0.09 divided by 4. So here we're going to have 1.0225 to the power 4 minus 1. 1.0225 to the power 4 minus 1 to give you 9.31%. So effective annual rate carries 3 marks. The answer you get, you multiply by 100, it's an interest rate. So help me. What is the effective annual rate if it was a monthly? Who wants to try? Effective annual rate if it was monthly. What is the formula? Effective annual rate is equal to what?
Equal to 1 plus
R
over 12.
For M minus 1, correct.
Minus
So 1, our rate is what? 0.09
0.09.
divided by M is what?
12.
12. Then here put what? 12 minus 1.
12 minus 1.
So 0.09 divided by 12 is 0.0075. So meaning we're going to have 1.0075 to the power 12. Then subtract 1 there. 1.0075 to the power 12 will be 0.09 So the final answer will be 9.38%. So this is what we call the effective annual rate. Okay, suppose it's compounded continuously. What is the formula? Future value is equal to what? PVERT. So our present value was 1,000. And here we put our E. Our interest rate was what? 9%. 0.09. And our time was what? 5 years. So zero 0.09 times 5 is 0.45. So when you do our E to the power 0.45, we get what? 1 point. This one will give us 1 point what? 1.57145. So when we apply the 1,000 here, we're going to get 1571.45. So you see, the more you compound, the higher the figure. The same applies weekly. It is 52. Monthly, it is 12. Daily, it is 365. These you can try at your own time, but you need to understand the whole principle. So this is basically what you needed to understand under time value of money. Question 2, Mr. Tembo wants to earn 5,000 after 4 years at 8% compound interest. How much must he deposit now? What are they looking for?
It's the present value.
Ooh, the present value. And what's the formula for the present value? Future value 1 plus R to the power time. So 5,000 over what? 1.08 to the power 4. Okay. Are we together?
Yes.
So when you divide that, we're going to get 3,675.15. So the present value must always be smaller than the future value. If it was compounded what? Semi-annually, what would have happened? Would have written 5,000 here. Here would have had what? 1 plus 8%. So 0.08 divided by 2. And the time we multiplied by 2. So 2 times what? Times 4. So here would have had 5,000. And here would have had 1.04 to the power what? 8. 1.04 to the power 8, which was 1.36. So 5,000 divided by answer, our final answer will be 3653.45. So you need to understand the whole principle. This was a single deposit, but it was annually. That's why we didn't do this. But if it's semi-annually, remember, you always divide the rate divided by M and the time multiplied by M. Don't forget that. How long would it take Mr. Tembo to double his 5,000 at 8% compounded annually? What are we looking for? How long? What are we looking for?
The time period.
The time
Time.
period, yes.
Period.
So future value is called what? Present value. 1 plus R to the power what? Time. So what is our future value? 10,000. And what is our present value? 5,000. Where's the 10,000 coming from?
To double.
Double, excellent. So when you divide both sides here by 5,000, we're going to have what on the other side? We're going to have a 2, right? If it was tripling, we're going to have a what? A 3. So how do we get rid of the t? What do we introduce?
By introducing log.
Good, log. So meaning here we're going to have log what? 2 is equal to t times log what? 1.08. So we divide both sides by log 1.08. Okay. What do we get? Divide this in there. So log 2 divided by log 1.08 will give us 9 years. So 9.006. So we're going to have 9 years. It will take 9 years. Okay, so this is what we discussed. Interesting. You need to know these principles. All these principles we've discussed today are very profound. I must mention to say time value is actually the base or the fundamental topic that you need to have for all these. It's like your calculus for this course. You need it in all the topics that are coming. Time value. All right. So now we got to a new concept which is called an annuity. What is an annuity? Annuities are a series of equal what? Periodic payments which are made at the beginning of the period or at the end of the period. Annuities are ordinary if are made at the end of the period. Annuity due is always made at the beginning of the period. We have examples of rentals, examples of mortgage payments, premiums, all these are annuities. So the key thing is there's a fixed deposit that is made at a predetermined time. So annuities are very important to understand. They represent a series of equal payments and receipts that occurred at specific number of equidistant periods. So if it's an ordinary annuities, it's made at the end of the period. If it's an annuity due, it's made at the beginning of a period. So examples of annuities, we have student loan payments, car loan payments, insurance, mortgage payments, retirement, savings, or even rentals. So if it's made today at the beginning of a period, it's called an annuity due. If it's made at the end of a period, it's called an ordinary annuity. So how do we compute annuities? For instance, you have 1,000 kwacha, okay, at an interest rate of 10%. At the end of 3 years, how much are you going to have? So ideally, you're supposed to have a 3,000 kwacha, but because of interest, it'll be more than 3,000 kwacha. So year 1, year 2, year 3, of 1,000 here, 1,000 here, and another 1,000 here. So we're going to calculate the future value of an annuity. Future value of an annuity. So we're just calculating future values. So the formula we use, the future value of an ordinary annuity due will be the payment, periodic payment. And we have 1 plus R to the power time minus 1 everything over R. So our periodic payment here is 1,000. Our interest rate here is what? 10%, so 1.10. And the years is 3 minus 1. The interest rate is 10%. So this is 0.10. So when you multiply that, in that bracket, you're going to find 3.310. So what you're going to have when you multiply that is 3,310. So this is how much you're going to have at the end of 3 years. Instead of having 3,000, you're going to have a 310 on top. This is called future value annuity. I said an annuity due is simply at the beginning of a period. So this is on the assumption that you're paying a 3,000 at the end of each year. But if you're paying at the beginning of each year, the answer will simply be the future value of an annuity times 1 plus R. So this will make what is called an annuity due. So the answer that we got here, 3,110, we multiply by 1.10. So since our interest rate is 10%, if it was 9%, multiplied by 1.09. So in this case, 1.10 times 3310, we get 8641. So this is what we call a future value of an annuity due. I repeat, suppose you have 12,000 and the interest rate is 8%. And this is running for 5 years. Let's calculate the future value of an annuity due. Formula is what? Future value of an annuity is the payment. And here we have what? 1 plus R to the power time minus 1, everything over R. So what is our periodic payment? 12,000. And what is our interest rate? 8%. So 1.08 to the power what? 5 minus 1. Then below, what are we going to put? Interest rate. 2.08, correct. All right. So what remains is an issue with the calculator. 1.08 to the power 5 minus 1 divided by 0.08. What you're going to get here will be 5.866. 5.866. So you multiply it by 12,000. What we're going to get is 87,879 and 990.144. So this is how much you're going to have at the end of 5 years. So when you multiply this one by 1.08, it becomes what? An annuity due. So when you multiply this one, it means you're making payments at the beginning of the period. So here you're going to have 950, 389,000.36. So this is what we call our future value annuity due. When you're dealing with present value annuity, you're looking at payments that are made today. How much? Year 1, year 2, year 3. If you're going to discount them today, you have 1,000 here, 1,000 here, 1,000 here. It's as good as telling you to say, instead of getting 1,000 next year, the second year and the third year, how much do you want now? So total here is 3,000, but if you're claiming it now, it must be lower. So using the formula, present value of an annuity is simply given by payment. Now take note of the formula, it will change. There it was 1 plus, here it is 1 minus 1 plus R. to the power negative t or negative n, same thing, over R. So the payment here is what? 1,000. Then here we're going to have 1, and here we're going to have 1.10 to the power, because our initial question we had was 1,000. How much we started with? The interest rate was 10%, and the period was what? 3 years. So here we're going to put negative 3 over 10%. So this is going to give you 1,000. And when you multiply all this here, you're going to get 2.487. So multiplying this is going to give you what is called our present value of an annuity. So this is 2,487. So to get the annuity due, the same thing, you multiply this by 1 plus R. So you're going to multiply answer times 1.10. So 1.10 times 2487. So this gives you 2735.7. So this is how we find the annuity due. So an annuity is a series of equal periodic payment. So suppose Mr. Tembo decides to deposit 1,000 every year from year 1 to year 3 at 10% compound interest. How much will he have if the deposit is made at the end of the year? So this is what? This is an ordinary annuity. So how much will he have if it is made at the end of the year, if it's made at the beginning of the year? So future value of an annuity, simply payment. Here it is 1 plus R to the power t minus 1 over the rate. So this is 1,000. Here we have 1.10 to the power 3 minus 1 over 1. So we've already calculated this one was what? 8310. If it's made at the beginning of the year, it is called the future value of an annuity due. So the 310, 1.10, and you get your figure. All right, so time value of money is very long, but I'd love to exhaust it today, but we'll exhaust it in the next session. However,